Well, hello my dear students of class 11. So today we'll be continuing with quantum numbers. So in our previous video we had discussed about quantum mechanical mode of atom. So today we'll be discussing about quantum numbers. Now these quantum numbers are very useful, okay, in the sense like a person's complete address is given by we can be knowing it by his exact location. Similarly, these quantum numbers, whenever we know about these quantum numbers, we would be able to know the complete address of an electron. So, quantum numbers are those index number which will be used to specify the position and energy of an electron. So, let me repeat it once again. Quantum number is defined as the index number which are used to specify the position. Number one is position and other one is what? The other one is the position and the energy of the electron. So, as I told you, these quantum numbers, there are in general, not in general, in specific, there are 4 quantum numbers. Now, when we know these 4 quantum numbers, then we will be able to tell the position of the electron. That means these quantum numbers are the addresses of the electron. So let's discuss about these 4 different types of quantum number. I told you there are 4 different quantum numbers. The first one is principal quantum number. Principal quantum number. Okay, so it is written as n. So it is designated as what? N. Now this n, okay, this gives us, this n could be any whole number 1, 2, 3, 4, etc. excluding 0. Now this n, the principal quantum number, gives us the level or cell of an electron, the energy level or cell of an electron. So number 2, principal quantum number gives us the energy level, okay, energy level or cells of an electron, in which it is located. Okay, so you can write of an electron of an atom. Okay, so this principal quantum number in general is giving us about what? It gives us about the information on which cell does this electron lie. Like for example, so if you want to know the complete address of a person, first you have to know where does he or she stay? Yes or no? In which building? Then we go to which floor does he or she stay? Yes or no? Similarly, this principal quantum number, till now you have the idea of what? This orbits or cells. It's not a specific location. It's just like in this particular building, this particular person stays. Okay? Now, that was your knowledge up to class ICSE level or class 10 level. Now we will be going into more specific. So we are learning about this quantum number. So this principal quantum number tells us about the cell. So if the value is 1, then you know when n equals to 1, then it is in the which cell? K cell. When n is equal to 2, then it lies in L cell. So this knowledge you already have it. Now let's move on to the next quantum number, that is azimuthal quantum number. So azimuthal quantum number is denoted by small letter l. It is also known as orbital or angular quantum number. So you can refer to your book. The second quantum number that we are going to discuss is what? Azimuthal quantum number. It is also known as angular or orbital quantum number. It is designated by letter small l. Now, this L, this is very important. Okay. Now, please look at it here. This L value depends on the value of principal quantum number. So, for a given value of n, for a given value of and here is what? And here is what? Principal quantum number. The value of L varies from n minus 1 to 0. The value of L will be equal to what? N minus 1 to 0. Suppose if you have, say, n equals to 3. Okay? So what would be the value of L? The value of L would be equal to n minus 1. Here n equals to 3. So 3 minus 1 is 2. 2, 1 and 0. So n minus 1 to 0. So the value of L for the given value of n equals to 3 are 2, 1 and 0. Okay? So this is very easy, very simple. But you have to remember this value of L, okay, will be n minus 1 to 0. Now, whenever it is, please look at it carefully. Whenever the value of L is 0, it is designated as S. Whenever it is 1, it is P. Whenever it is 2, it is D. And if it is 3, so here in this case, you have for 0, for L equals to 0, it is given designation as what? S. For L equals to 1, it is designated as what? P. For L equals to 2, it is given the designation as D. If L equals to 3, then it is designated as F. Okay? So these are the things that you have to know it. And this is very simple. Here you just have to remember them. Now, see, here, in this case, if you have this from the value of L, this absolute quantum number, what can you know? What information is given? Information regarding its angular momentum is given by this value of L. Please don't forget, it determines angular momentum, okay, of an electron. And it also gives you the number of subcells. This principal quantum number gave you energy level or cells. Now this next quantum number gives you the number of subcells in a cell. Please remember this part. So here we are discussing about second quantum number, that is Hazardous quantum number. I told you it gives you information given is what? Information given by L. Given by L. L is Hazardous quantum number. It gives you the number of subcells. Please remember subcells in a cell. Okay, so this gives you number of subcell. Now for the given, to find this subcell, what you have to know? You have to know the value of L. So whenever you have, when n equals to 1, the value of L could be 0 because it is n minus 1 to 0. Therefore n minus 1 is what? 1 minus 1 is 0. Now this shows us that this K cell consists of only one subcell. So this corresponds to K cell. Okay? And it consists of only one subcell. One subcell. Why one subcell? Because the value of L in this case is only 1. Even though it is 0, the value 0 is also a value, that is only one value. Therefore, this K cell will be having only one subcell. Okay, please remember this one. Now, let's move on to this part here. S, P, D, and F. Now, whenever you have the same principal quantum number is n. Now, here, what you have to know is, higher the value of L value, that will be having more energy. For example, suppose you have n equals to 3. Yes or no? And for this n equals to 3, you already know the value of L would be 2, 1, and 0. Yes or no? Now this 0, as I told you, corresponds to S, this to D, and this to S. This is P, and this is D, as we have done here. Now, in case of this particular example, the value of principal quantum number is 3 in all these 3 cases. Now, depending on the value of L, in one case it has value 2, which corresponds to D, 1 to P, and 0 to S. Now, based on this, you can say that higher the value of what? This azimuthal quantum number, they will be having more energy. Therefore, you can say that this D is having higher energy than P, and P is having higher energy than S. Okay? So you have to just remember this trend. Now let's discuss about the third type of quantum number, which is magnetic quantum number. The third type of quantum number is what? Magnetic quantum number, which is designated by n small m or small m l. So, which is designated by n or m l. Okay? Now here, what you have to know is, now whenever under the influence of external magnetic field, please listen carefully. Under the influence of external magnetic field, what will happen is these electrons will not be oriented in just one same direction. Now they might be oriented along the line of this magnetic field that is parallel, or it could be in any other orientation. Now depending on that, what will happen is, now different electron gets excited to different extent. Okay? And because of this, we have discussed about splitting of hydrogen spectrum. Yes or no? Now splitting of this spectral line takes place under the influence of what? External magnetic field. Now, this effect is known as what? Zeeman effect. You should not be forgetting this. Zeeman effect. Under the influence of magnetic field, there is further splitting. Okay? And this is known as what? Zeeman effect. Now, this, under the influence of this external magnetic field, different electrons will be going to different orientations. They will be having what? Different orientation, and these orientations are known as what? Orbitals. Now, based on their energy, they will be going to different orbitals. Now we are coming to what? Orbital part. The first principal quantum number gives us what? The number of cells. Second quantum number, that is azimuthal quantum number, tells us about sub-cells. Now this magnetic quantum number tells us about orientation. Okay, they will be oriented in different ways under the influence of external magnetic field. And this orientation is known as what? Orbitals. And here we are discussing about what? Orbitals. Now, in a particular flat of a person, we are talking about address. Once you enter inside, you will come to know how many rooms are there in that particular flat. Yes or no? Similarly, these orbitals are like room, okay? Room for the electrons. How many rooms will be there, or in which room these electrons are occupied? We are talking about, please don't forget, we are talking about the complete address of an electron. So first cell, then we went little inside, that is subcell. Now orbital. Orbital, you can relate it to the number of rooms of a particular person in a particular flat. Okay? So whenever you have this, if you know the value of L is what? Previous quantum number, that is azimuthal quantum number. For a given value of L, M will be having value, please look at it, from minus L to plus L. This is for a given value of L. The value of M, that is magnetic quantum number, will be from minus L to plus L. For example, if you have, say, L equals to, say, 2. Now for this particular example, if you follow this particular relation between magnetic quantum number and azimuthal quantum number, you will come to know the value of M, that is magnetic quantum number. So it has to vary from minus L to plus L. Here it will be minus 2. Please don't confuse, this is 2. From minus L to plus L, whatever number, whatever digit comes in between. Okay, so minus 2, minus 1, 0, 1 and 2. So in this particular case, how many values do you have? You have 5 values of magnetic quantum number for a given value of azimuthal quantum number, which is 2. So in a sense, you can tell that whenever it is L equals to 2, now this was corresponding to, please look at your note, you have noted it down previous, just today, few minutes back we had discussed, whenever it is L equals to 2, it is SPD. It is given the designation D. Now this D, particular D, will have how many values? 1, 2, 3, 4, 5. That means this D will have how many rooms? We are talking about the number of rooms. 1, 2, 3, 4 and 5. Okay? So in a D cell, how many? In a D subcell, how many rooms are there? 1, 2, 3, 4, 5. How did you come to know? You came to know it from the value of M. Okay? Which were minus L to plus L. That means you have 5 values. Therefore, this D subcell will have how many rooms? It will be having 1, 2, 3, 4 and 5 rooms. Similarly, for a given value of, say, L equals to, say, 1. Now this would be corresponding to P subcell. Yes or no? And what would be the value of M then? M would be plus 1, 0, minus 1. Or you can write the other way also. Minus 1, 0 and 1. So how many values are here? 1, 2, 3. So this will correspond to P subset, and it will be having how many rooms? 3 rooms. Hope this is clear. This is very easy. You can refer to your book if you have any confusion. So now let's discuss about the last type of quantum number, that is spin quantum number. Okay? As you know, under the influence of what? Magnetic field. We are discussing about external magnetic field. What happens? The electron, okay? The electron, they can either revolve in anti-clockwise direction or they can revolve in clockwise direction. So this is clear. They can rotate in a clockwise direction or they could rotate in a anti-clockwise direction. Based on that, we have another, the fourth type of quantum number, that is spin quantum number. Now, whenever this electron they rotate in clockwise direction, they will be having positive half value, and if they are rotating in anti-clockwise direction, then they will be having minus half spin quantum number value. Now, in a particular room, and please don't forget, this room here is the orbital. In one particular orbital, if electron is pointed upwards, the electron is shown as pointed upward, then it will be having plus half value, which is clockwise, which denotes the rotation in clockwise direction. And if it is pointed downward, then its spin quantum number value is minus half, which has to be anti-clockwise spin of the electron. Now, this is what we come to know from the spin quantum number. Now, one more thing that you have to remember is a particular room, that is orbital, one particular room has the maximum capacity of 2 electrons, and if it is occupying 2 electrons, then one spin has to be clockwise direction, the other one has to be downward, which means anti-clockwise direction. Now, if you calculate its total spin quantum number value, then it will be this is plus half and this is minus half. If you calculate that, it comes close to 0. So whenever in a particular orbital, if 2 electrons are present, then they have to be what? They have to have opposite spin, and their overall spin quantum number value will be 0. Now, if it is having 1 electron, say 1 electron, then it will be having plus half value. So hope this is clear. Now this particular spin quantum number will tells us about what? Maximum number of orbitals in a subset, which is given by n square. So what does it give us? What information does this spin quantum number give us? It gives us the maximum number of orbitals in a subset, which is given by n square. Okay, so now this particular topic is very important, not only for your class 11 but also after class 12. If you wish to go in the field of medical science or in the other field for competitive examination, a sure short question will be asked from this particular section. Okay, so let's try to solve one of the numerical. Now in your book, as I have been telling you, you have plenty of these numericals. Okay, these problems which are solved as well as which are unsolved. So let's take one particular example or a problem. So an electron is present in 4f subcell. So the electron is present in 4f subcell. What the question asks us? Give the possible value of its 4 quantum number. So if an electron is present in 4f subcell, then what are the values of n? N equals to what? L equals to what? Then you have magnetic quantum number as well as you have spin quantum number. So they are asking you the possible value. If that particular electron is present in which subset 4f. Now, from this value 4f, this 4, the coefficient always denotes the principal quantum number. Please listen carefully. This 4 is principal quantum number, that is n equals to 4. Now, if you know n equals to 4, then you can know the possible values of n. The possible value of L would be n minus 1 to 0, which is here n is what? 4. 4 minus 1 is 3. 3, 2, 1 and 0. So these are the possible values of what? L. But the question has asked you the electron is located in which subset 4F. So you have to identify out of these 4 values which one is F. So as I told you, this is S, this is P, this is D, and this is what? This is F. Yes or no? From our discussion about azimuthal quantum number, I told you this 3 corresponds to what? F. So the electron is lying in which? This subset F. So F denotes the value of L should be what? 3. So therefore, your L value will be equal to 3. Now if you know the value of L, then you know the value of M magnetic quantum number can also be calculated. M will be from minus L to plus L. So the L value is what? 3. So what are the possible values of M or Ml? It is minus 3, minus 2, minus 1, 0, 1, 2 and 3. So minus L to plus L. All the values in between. So the value for Ml could be from minus 3 to plus 3. And the fourth one, that is spin quantum number. As I told you, the spin quantum number can have only 2 values. That is either plus half or minus half. So this is it. From this particular knowledge of these 4 quantum numbers and their relation between each other, we will be able to calculate all the possible values of this particular 4F subset. Likewise, you can try for other subset as well. So there are other types of questions related to this particular quantum numbers. Please practice them and always welcome. As I have been telling you, any problem, we have the WhatsApp group now. So any questions, any problem, you can ask me freely only. You can ask me. See, I'll be explaining you there as well. Okay? So never ever hesitate to ask any doubt. Hope you will practice this properly, and I expect some questions from all of you. Take care. Thank you.